And welcome back. We're going to continue our look at adding and subtracting rational expressions in this video. This is the second part of the video where we already added and subtracted two just rational numbers, reviewing that. Again, this is from the Unbounded lesson here. You should have this paper from your teacher. All right, so let's take a look here at number 3. So again, when it comes to adding rational expressions like pi over 4 here and root 2 over 5, the same rules still apply. Okay, so again, don't be scared by the fact that we have a pi here or that we have a square root here. It's really these two numbers that we want to be the same. So we're going to look for our least common denominator here, okay, or just a common denominator here. So what would that look like? Well, let's look at multiples of 4 and multiples of 5. So multiples of 4 will be stuff like 4, 8, 12, 16, 20, 24, 28, 32, etc. And the multiples of 5 would be 5, 10, 15, 20, 25, but we can stop because we see that we have a common multiple there of 20. So we can multiply the 4 by something to get 20. We can multiply the 5 by something to get 20. Okay, in fact, we'll multiply the 4 by 5 over 5, so we get 20 there. And we'll multiply the root 2 over 5 by 4 over 4, so we get 20 there as well. So we'll get 5 pi over 20 plus 4 square root of 2 over 20, which equals 5 pi plus 4 times the square root of 2 all over 20. And there's our final answer. We can't really add 5 pi and 4 root 2. They're not common, or they're not like terms, so we just have to leave it that way. Okay. Number 4. Lots of letters in here, right? Only one number really pops up, but we can still get a common denominator. What will our common denominator be here? Well, if you look at the denominator here, it's an m, here it's a 2m, and here it's an m. So we can see that both of these already are like, but they're not like with this one. What can we do with these two here to be like with the 2m? Multiply the top and bottom by 2. Okay, so we'll get 2a over 2m plus b over 2m minus 2c over 2m. Okay, now we have that common denominator for all three terms there, so we can just combine our numerator. Now again, none of these are like, so we're just going to have 2a plus b minus 2c, like this, all over 2m. Okay, since these are all different variables, they can't be combined together. So this is the best we can do. Okay, so example 1 here, we're asked to perform the indicated operations below and simplify. All right, so again, we're going to add, and we can see we have a rational expression and another rational expression. This is a 4, this is a 5. We already had a 4 and a 5 denominator, if you remember from earlier. Okay, right here, where we had the 4 and the 5 denominator, we needed to multiply one by 5 over 5 and the other by 4 over 4. So we'll do the same thing here. I get a common denominator of 20. Okay, so we'll multiply this by 5 over 5 and multiply this one by 4 over 4 to get that 20 in the numerator, or sorry, in the denominators there. So this become, now that 5, what does it multiply to? Multiplies to the a and to the b here. So we're going to have 5a plus 5b over 20. Okay, and the 4 will also distribute to the 2a and the minus b. So it's going to become 8a minus 4b over 20. And now add. Okay, the 20 will be our new denominator, but 5 and 8 will make 13a. Right, so they add together to make 13a. And the 5b minus the 4b becomes 1b. And there's our answer. Okay. We will pause there, and we'll get to letter B in the next video.